Hi, welcome to this 4AC learning video. In this video, we want to look at example 1.6c, which is found in your lecture notes. Example 1.6c reads as follows. For the sinusoidal waveform or voltage, Vt is 200 sine 628t plus 45 degrees. Notice there's an initial phase angle. We want to find the peak-to-peak value, VPP, the voltage signal. We want to find the RMS voltage of the signal. And we want to find the frequency. And we also want to find the voltage at the time when the t is 0.04 seconds. Next, we want to find the time it takes for the waveform to complete 3 cycles. And then we want to sketch one of the cycle waveform, indicating clearly the peak value, the period, and the phase shift. And for the last part of this question says that if the above signals applied across a coil of inductance XL is 10 kilo ohm, we are asked to write down the sinusoidal expression for the current flowing this inductive coil, through this inductive coil. Okay, let's see how we can answer this question. Alright, we can start by writing out the standard sinusoidal expression. And we can compare the standard expression and this one. Then we can determine what is the peak-to-peak value. Now, first of all we need to do is to determine the V peak is, from this comparison, is 200 volt. Therefore, peak-to-peak value is just 2 Vp, which is 2 times 200, which is 400 volts. Right? Now, Vrms we learned earlier is actually V peak divided by root 2. Now I know V peak is 200 divided by root 2. That gives me V peak by 200. That gives me 141.42. Remember, Vrms is the effective voltage. Now, omega, if you compare this waveform, omega is just 628 radians per second. Therefore, the frequency is just 628 divided by 2 pi, because omega is 2 pi f. So gives me a frequency of just 100 Hz. Therefore, the period is just 1 upon frequency, which is 1 upon 100, which is 0.01 seconds, or 10 milliseconds. Okay, so now we are up to here. Part 1, Part 2, Part 3, and Part 4. Now, Part 4 wants me to determine the voltage at the time when t is 0.04 seconds. So what I can do is just write down the expression 200 sine 628, but this time t, I substitute the 0.04 second in there, plus a 45 degrees. Now remember something here. This expression is in radian. This expression is in degree. So we need to be mindful to convert the radian equivalent to degree. Okay. So in this example, 628 628 times 0.04 is equals to 628 times 0.04 is 25.12 radian. 25.12 radian. So if I were to divide this by 2 by pi times 2016, minus 360, 360, 60. I should get an angle of 1439. 1439 plus 45. So I will have 200 sine of 1439 plus 45. So that will give me 1439 plus 45 degrees. Looks very big number. I sine it and multiply it by 200. This gives me a voltage of 139.608 volt. Next, we want to find the time to complete the 3 cycles. In other words, 3 times the period t. Now, period t we have calculated earlier is 10 milliseconds. So here will be 3 times 10 milliseconds, which is 30 milliseconds. And we are asked to draw the waveform, right? So the waveform will be 200 maximum, and because there's a plus 45, that means it starts earlier, so this is the waveform. Okay, t here is 1 cycle, so I will draw this, that this is time in milliseconds, this is V in volt. And the last part of the question is that if this signal is applied to a coil, it's a coil of inductor XL, and we apply this signal. Now effectively, what does a coil inductor do is that it adds in another 90 degrees to the whole cycle for the current. So for current, it will be 200 sine 628t plus 45 degree minus 90 degrees. That is the effect of an inductor. It actually creates a phase shift of 90 degrees. And we have to divide the inductance there, which is 10 kilo ohm. 10 k ohm. So here is 10 k ohm. So effectively the current becomes 2 milliamp, become milliamp basically. So it's 2 sine 628t minus 45 degrees milliamp because of this. Sorry, not 2, it's 20 milliamp. Okay, so that's how you get this one. That's the answer. So effectively an inductance creates a 90-degree shift for the current. So that's the expression for the current flowing through the inductor. Okay, that's all for this video. Bye.